correct topic. That is is going on, as you know, IoT is for everything. So if you want to do anything, IoT plays very important role. So selecting this topic, that IoT for smart grid, really it is very nice and very unique idea to have FDP on this topic. So today is the second day, and my talk will be about the IoT for smart grid. I think there will be a lot of talk. Yesterday you might have heard about smart grid. As you know that in present scenario, the present grid, which we feel it is unfit to satisfy the customers. As you know that customer expectation is day by day is increasing. Am I right? If you see total productions will come around 3,61,000 megawatt, whereas our demands are every day is increasing. So demand never met the supply. So due to shortage of demand and due to shortage of supply, we cannot increase our supply all of a sudden. So you have to use the resource available in an efficient way. Understand? That's why I'm looking for a smart grid. As you know that grid becomes smart when you have the different features will be there in the grid. So I think that you might have heard about what is the smart grid. So grid will be basically the evolutionary grid, which will have a lot of automations, modernized techniques will be there, so that which will be alert to the any situations. It may be disasters, it may be cyclone. The grid must be enough robust sorry, to overcome all this problem. So in that scenario, this smart grid plays very important role. As you know, smart grid is nothing but where customers as well as your, if you see, sellers or the utilities play an important role. It is a bidirectional power flow. Now in conventional power flow, you just talk about the TNEB. What happens if the TNEB is now if you see it is coming bearing loss around 20,000 crore. So TNEB, if you see what happened, that tariff or rate, whatever they are fixing, it is one way. The customers are not actively participate. So it is just like if it is a vertical approach. If a smart grid is better in a horizontal approach. In you talk about in conventional grid, you are talking, if you say as head of the grid, you take decisions and you impose the tariff. So role of customers is very, if you say, they are not actively participates, they never decide the tariff, and their job is only to pay and use. So there if you see a quality of electricity or quality of grid expression will be wrong. See, if you see present grid, what happens, you are paying electricity, you don't know how this bill is coming, it is not transparent. But in smart grid, you will have a smart meters where you can see the day-to-day tariff. So in smart meters, this IoT plays an important role. See, can you imagine anything without, what is IoT? Internet for, you can say Internet for things or Internet of everything. Can you imagine anything without Internet? So you are now a digital array, and this, if you see pandemic, this Corona, COVID-19, this IoT plays very, very important role. You do anything. You do your banking or transactions or your vehicles, anything you are doing on digital way. So these are very important topics that your institute has selected, because as present scenario, everything, prime ministers and everybody is giving more emphasis on making a digital arena. So in digital arena, without IoT you cannot do it. So IoT means what? Internet of things. So you do anything, you have to apply the internet. And this is very, very important in smart grid. You have a lot of devices, communication devices. You have LAN, you have FAN, or you have PAN, or you have WANs, you have PNU. All these smart tools cannot be used, or ZigBee, or it was 5G, 4G, cannot be used without IoT. So IoT is, initially I was thinking, if you will see in our institutes, IoT subject is generally taken by computer science departments. But nowadays, if you will say, it is essential to all. From childhood you are learning IoT. See, you suppose you are studying the LKG or UKG, your class nowadays going digital mode. You understand? So in that case, you will see IoT is very, very important role. It is nothing but connecting machine to the man. Am I right? It is connecting with the machines So this topic is very interesting topics, and I'll be talking about IoT, what do you mean by IoT, what are the different applications are there, and what are the IoT standards. So we will be briefly discuss about application standards and more related to smart grid. As I told you, in smart grid, if might have seen there are different components are there, like you might have heard about PMU, pressure measurement unit, WAMS, that is wide area monitoring systems. So in all these tools of that is a DMS, data management systems, or AMI, all these tools of smart grid cannot be, if we say, used without help of internet. So IoT plays very, very important role. So let us start this IoT introductions, then I will be talking about various applications of IoT. One minute. So let us talk about IoT, how it is useful in our day-to-day life, and it has a big features in future also. So if you see, this is the Internet of Things, you can see all these devices are connected through Internet. 1 minute. Sir, ମୁଁ କ୍ୟାବିନ୍ ଅଛି ହେଲା, ଆପଣ ଘଣ୍ଟେ ପରେ ଆସନ୍ତୁ, thank you. ମୁଁ ଗୋଟେ ଟକ୍ କରୁଛି, ମୁଁ କ୍ୟାବିନ୍ ଅଛି, ମୋ କ୍ୟାବିନ୍ ଅଛି ହେଲା. Oh, more room, thank you. So if you see this IoT, as I told you, is nothing but Internet of Things. Okay? So things can be operated in Internet. So Internet, you know how much important for us. Nowadays, if you see basically in this period, we are taking class and everything by Internet. So it has played very, very important roles. So we will see what is Internet of Things, how IoT works, what the current status and future prospect of IoT, how to do knowledge management, future of IoT, potential of IoT, application of IoT, what are the technological challenges of IoT, what are the criticisms and controversies of IoTs. Then we will go to the reference. So what is IoT? As I told you, this is network of physical object. IoT comprises things that have unique identities and are connected to the Internet. So IoT means what? Internet of Things. Just imagine the world without Internet. Then the focus on IoT is in the configurations, control and networking via the Internet of devices or things that are traditionally not associated with the Internet. The examples are pump, utility, meter, car, engine. IoT is a new revolution in the capabilities of endpoints that are connected to the Internet. So it is nothing but, if you see the revolutions, the scope of IoT is not limited to just connecting things. So you just connect the things or devices or machines to the Internet. That is not the scope. It allows these things to communicate and exchange data. So what is going to do? It is going to control and informations. It will be exchange the data as well as communicate. Sorry. Processing on this data will provide us various applications towards a common users or machine goal. So if we process this data, it will provide a common goal. So what is the IoT definition? The IoT can be defined in two ways based on existing technology and infrastructures. That is definition of IoT based on existing technology. IoT is a new revolution to the internet due to the advancement in sensor networks, mobile devices, wireless communications, networking and cloud technology. So this is based on the existing technology. Based on infrastructure, what is IoT? IoT is a dynamic global network infrastructures of physical and virtual objects having unique identities which are embedded with software, sensors, actuators, electronics, and network connectivity to facilitate intelligent applications by collecting and exchanging data. So IoT can be defined in two ways, based on the technology we are going to use and based on the infrastructure. So basically if you will see from the definitions, what is going to do, it has a unique identities which are embedded with software, sensors, actuators, so electronics and networks, connectivity. So if you see IoT is more related to the smart grid. You may think why IoT is required. You see, in smart grid what we should do? In smart grid we will have a lot of sensors because whenever any fault is occurs, you should be able to sense very fast. Then you have actuators, then you have electronics and networks. So then if you see smart grid is based on the connectivity. You more customers and the utilities must be connected to each other and use the intelligent applications. So that's why IoT is very much related with the smart grid. So things in the IoT sense can refer to a wide variety of devices such as heart monitoring implants, biochip transponders on farm animals, electric cams in coastal waters, automobiles with built-in sensors, DNA analysis, devices for environmental or food monitoring or field operation devices that assist firefighters in search and rescue operations. These devices collect useful data with the help of various existing technology, then autonomously flow the data between other devices. So what you should do? See, why you should use the internet? Correct? Suppose I am giving a talk in internet. So what are doing? You are getting the information from me. Am I right? So internet, if you see, it is a media like this IoT, Internet of Things. It is a media by which you are getting a lot of data. So that data may be required to do some specific operations. So this can be done by using sensors. IoT can sense. So this is IoT, as I told you. If you see the history of IoT, the concept of Internet of Things first became popular in 1999 through the Auto ID Center at MIT and related market analysis publications. Then then the radio frequency identification was seen as prerequisite for the IoT at that point. If all objects and people in daily life were equipped with identifiers, computers could manage and inventory them. Besides using RFID, the tagging of things may be, see now all of things are tagging. You just check by the internet, it can show the features of the product. Things may be achieved through such technology as near field communications, barcodes. So you might have seen in you go to a big store, department store, or talk about Walmart, or you talk about even small shop, they have a barcodes or Bluetooth or digital watermarking. So these are technology we are using to tagging so that you can know about the things. If you put the code, you can know the things and it can tell out the features. So idea moved from Internet of people to Internet of Things. The Internet appears everywhere in the world. So Internet of people, how it can use for things. You can see Internet appears everywhere in the world. It is primarily connection between people. Internet of Things is a plan to connect things also using the same medium. Internet of Things is a plan to connect things also using the same medium. So this is a difference. See, internet we are using initially for people. Now we are going to use for things. So Internet of Things evolutions, pre-internet, human to human, fixed and mobile telephony, SMS. Internet of content, email, informations, entertainment. That is smart network. The smart plus IT platforms. Internet of services, Web 2.0, e-productivity, e-commerce. Then you have smartphones and applications. Internet of people, like you have now Skype, Facebook, YouTube, WhatsApp. These are the Internet of people, social media. Then now it has come to Internet of Things, that is machine to machine. That is identifications, tracking, monitoring, metering, automation, actions, payment. That is smart data and ambient context. So difference between machine to machines and IoT. Point-to-point communication is usually embedded within hardware at the customer side. Here in IoT, devices communicate with IP networks incorporating with varying communication protocols. Many devices use cellular or wired networks. Data delivery is relayed through a middle layer hosted in the cloud. The devices do not necessarily rely on an internet connections. In the majority of cases, devices require an active internet connections. Limited integration options as devices must have corresponding communication standards. All limited integration options but require solutions that can manage all of communications. IoT, people connecting with things. You can say ECG sensors, you have motion sensors, you have in your hand, motion sensors. You have an internet, so you have internet of home, computers. So this is a display in these sensors. What will do? They will get data through internet. What will happen? That will display in the monitor. So you can control the things. IoT things connecting with the things. You see here, you have a car, you have your automobile, complex and heterogeneous resources and networks. You see here, you have machine to machine 2, machine to machine 3. Inside machines, use for internet, 3G or 4G or Wi-Fi, all those things can be controlled. That is given in this diagram. Unlocking the massive potential of IoT, that is improve performance, it reduce cost. You do anything, main objective is it must reduce the cost. It must be innovative services. You can do innovative services, then you can have a new revenue stream. So what is the main objective or goal of the IoT? Why you should use IoT? The main goal of IoT is to configure, control and network the devices or things to internet which are traditionally not associated with the internet, that is thermostats, utility meters, a Bluetooth connected headset, irrigation pumps, sensors or control circuits for an electric taxi engine that make energy, logistic, industrial, control, retail, agriculture and many other domains matters. So generally, which are not connected, you can connect the internets. So blooming opportunity, if you say, as a consumers, you can have smart home control. That is what you mean by smart home. That is also a big topic. You have lighting, security, comfort, optimized energy use, maintenance. Then you have retail, that is a product tracking. Then you have inventory control, focused marketing. Then opportunities that in medical you can use for wearable devices, implanted devices, telehealth services. In military you can use resource allocations, threat analysis, proof monitoring. In industrial you can use smart meters, warehouse sensing, manufacturing control, climate control. In automotive you can use for parking, traffic flow, anti-theft locations. In environmental you can use species tracking, weather predictions, resource management. In agriculture you can use crop management and soil analysis. So if you see, opportunities are very high. But if you are able to use, then you will become, it will be successor. So if you see, it has so many applications. So that's what I'm telling, in present day, without IoT, survival will be also difficult. So what are the characteristics of IoT? Various kinds of IoT are, it is, as I told you, the dynamic and self-adapting, is self-configuring, interoperable communication protocols, unique identities, integrated into information networks. Then if we continue what the characteristics of IoT are there, these are dynamic and self-adapting. The IoT devices can dynamically adapt with sensed environment, their operating conditions, and user context and take actions accordingly. For example, surveillance systems. Self-configuring. IoT devices can be able to upgrade the software with minimal interventions of users, whatever they are connected to the internet. They can also set up the network. A new device can be easily added to the existing networks. Whenever there will be free Wi-Fi access, one device can be connected easily. That is self-configuring. See, suppose in mobile you once connected Wi-Fi, next time you disconnected, connected automatically. That is very important. Then interoperable communication, that is IoT allows different devices to communicate with each other as well as with different networks. For example, MI phone is able to control a smart AC and smart TV of different manufacturers. That's what I'm telling. IoT, what it do, it can allow different devices to communicate with each other as well as with different network. That is very, very important. See, in phone you are able to control your smart AC or smart TV or different manufacturers. Then what is unique identifiers? The devices which are connected to the internet have unique identities. Their IP address through which they can be identified through the networks. The IoT devices have intelligent interfaces which allow communicating with users. It adapts to the environmental context. It also allows the user to query the devices, monitor the status, and control them remotely. In association with the control, configuration, and management infrastructures. The next is integrated into information networks. The IoT devices are connected to the network to share some information with other connected devices. The devices can be discovered dynamically in the network by other devices. For example, if a device has Wi-Fi connectivity, then that will be shown to other nearby devices having Wi-Fi connectivity. The devices SSID will be visible throughout the networks. Due to these things, the network is also called as information networks. The IoT devices become smarter due to the collective intelligence of the individual devices in collaboration with the information network. For example, weather monitoring system. Here the information collected from different monitoring nodes. Then what are the standards are there? Various IoT standards are HTTP, Hypertext Transfer Protocol, COAP, Constant Application Protocol, WebSocket, MQTT, Message Quick Telemetry Transfer, XMPP. So you know what the use of standards in
Sir, sorry to interrupt you.
Hello?
Your screen is not visible, sir. Your screen is not visible.
It is not visible.
No, sir. Everyone is messaging.
I don't know. So can I start once again? Let me
Yes, sir.
Now it's not visible?
No, sir.
Okay, I'll bring up to what slide it was visible?
Only peak, your peak is visible. That Radha Krishna one.
Is that?
Yeah.
If it is not visible.
Kindly share your screen, sir. Kindly share your screen.
Deepika Sharma is presenting. Can you stop in presentations? That's the problem, that is not visible. Deepika Sharma is presenting.
Deepika Sharma. Please stop sharing your screen.
That's why
Deepika Sharma. Deepika Sharma, please stop sharing your screen. Sir, you share that will be overwritten, sir. You share your
No, Deepika Sharma in my display showing Deepika Sharma is presenting. So that's why it was not visible. Okay. Okay, share now. Okay, it will come now. Okay, is it visible now? Dr. Jagdish Kumar, is it visible now?
No, sir. No. No,
Huh?
it's not visible.
Sir, visible.
Sir, it is visible.
Sir, visible, sir.
Okay.
It is
So,
visible, sir.
what slide I have taken? Just 1 minute. Dhiranji. Just give me. This talk will go for
Visible, sir.
It's about IoT used for smart grid. Yeah, 1 minute. Just. Okay, all the best. So now I think I don't know up to what I was taking. Hello. Hello. Dr. Jagdish Kumar. Hello. Is it visible? Is it audible?
Yes, sir, you are audible and screen is also visible. Yes.
So up to what slides you have seen? Can you tell me?
Coming opportunity.
Up to this,
The
correct?
protocols, so the protocols which are IoT involved. That is.
This one.
सर आगे थोड़ा आगे सर हम लोग तो मैसेज
Slide number, do you remember goal of IoT? This is visible, correct?
yes sir, it's over already. I've told it. The protocols which are used in IoT, MQTT, and that's all.
Okay. So this one. So this is the IoT
Yes, sir,
standard.
this one.
Thank you for remembering me because I may not know what is visible or not. I will keep on talking. Okay. So you just this time you tell me it is not visible. Okay. So if I say IoT standards are very, very important. You know that you do anything, you should measure. How to know it is correct or wrong? So there is some standards are there. So here if you see what are standards are there in IoT, you have HTTP, COAP, WebSocket, MQTT, XMPP, DDS, AMQP, Zigbee, Bluetooth, 6LoWPAN, IEEE, 802.15.4, Modbus, MBus. So these standards, what they use? See, as I told you, as an electrical engineer, if you are, you will be knowing IEEE 519 standard. What the standard is telling? That it is talking about the harmonic presence. It's talking about the harmonic presence. What is the percentage of harmonics present? So that you can tell it is quality power. Similarly, the standards are useful for IoT to define the different parameters required. So if you see HTTP, so these are the fundamental. If you see many times in our day-to-day life, you are using HTTP. Am I right? When you write a website, you are using HTTP. But what is HTTP? What is the full form and why you should use? HTTP is a web transfer protocol. It's suitable for web browsings. When you do browse, you write HTTP, any website you are writing, it is a stateless protocol. It uses URA to identify HTTP resources. It uses request response model. It uses client server architectures. It uses put, get, post, delete, head, trace, access method to communicate with the resources. What is called It is a web transfer protocol. It is designed to work with HTTP. It is suitable for machine-to-machine communications. It is applicable for constant environment with constant device and networks. It is a stateful protocol. It uses UDP. If similarly you have web socket, it allows full duplex communication over a single socket communication to provide data transfer between client and server, keeping TCP connection open. It is a stateful protocol. It uses TCP as transport layer protocol. It uses request response communication model. MQTT is a low weight messaging protocol suitable for constant environment where devices has low processing capabilities, less memory and less bandwidth. It uses TCP as transport layer. It uses publish subscribe model. It uses client server architectures. IoT standards, then you have XMPP. It is a decentralized protocol. It is suitable for real-time communications and streaming small chunk of XML data between network entities in real time. It uses TCP as a transport layer protocol. Client server architecture allows client to server and server to server communications. It provides a range of applications such as messaging, multi-party chat, voice, video call, gaming. DDS, it is a data-centric middleware standard. It provides device-to-device, machine-to-machine communications. Uses publish substrate model. It provides quantity of service control and configure reliabilities. AMQP, it is an open application layer protocol for business messaging, supports point-to-point and publish a subscribe model routing way. So ZigBee, you know already, it is a new wireless technology based on IEEE 802.1 15.4 standards. It is created for remote control and sensor networks. So many students used to project by using ZigBee. It is created by ZigBee Alliance. The members of this alliance are Philips, Motorola, Intel, HP. It is implemented with low cost. It provides reliable data transport, short range. So many demerits, it is used for short range. Very low, and benefit is that it uses very low power and adequate security features useful for home automations. Modbus, it is a serial communication protocol. It is developed by Modicum, published by Modicum in 1979. It is used for PLC, that is programmable logic controller. It is a used method for transferring information over serial lines between electronic devices. It is an open protocol. It is free for manufacturers to build into their systems. Similarly, we have MBus, that is meter bus. It is an European standard for the remote reading of gas or electricity meters. MBus is also suitable. MBus is also usable for other type of consumer meters, water meters, gas meters. The MBus interface is made for communications on 2 layers, making it cost effective. So if you see PLC, as you know that PLC is very important device you are using day to day for communication. That is nothing but power line communications. It is a communication technology that enables sending data over existing power cable. So the power cable can both power of the device at the same time control or retrieve data in a half duplex manner. So if we see these devices are nothing but what I am telling, ZigBee or your PLC or HTTP, MBus, they are very so they are very important. As you know that in smart grid, when you communicate with the consumers, that communication should be faster. So you use broadband. I can tell you can use broadband, BPL broadband power line, or you can use PLC also. So if you see these IoT standards are used also in smart grid. You know very well, like SCADA. SCADA is always compared with the PLU. SCADA is what is SCADA? That is supervisor control and data acquisitions. So it will say why you need this topic or this communications is very important in a smart grid. So when you talk about smart grid, if suppose somewhere some fault occurs, it takes more time to sense, then what happens? Whole things may be collapsed. So wherever abnormal things are happening, you should be able to communicate faster. That's why you need the very strong communication system. That's why using BPL or PLC and this you are using SCADA. SCADA, what is going to do? You will be controlling data in a remote control centers. Now SCADAs are going to be replaced by PLU. That is phasor measurement unit. So what I'm telling, these devices are also, you talk about water or you talk about gas. That consumptions, how to know how much gas somebody is taking or water is taking when you have a common supply. So that metering system is very, very important. That is the job of meter bus. So how IoT works? As you know that IoT plays very important role in day-to-day life. How it is working? It is working by internet. Internet of Things is not the result of a single novel technology. Instead, several complementary technical developments provides capabilities that taken together help to bridge the gap between the virtual and physical world. These capabilities include communications and cooperations, addressabilities, identifications, sensing, actuations, embedded information processing, localizations, user interface. So if we say IoT is, if we say it is when something importance, it also have different technology integrations. Like you have communications and cooperations, you want to address or you want to identify, then you sensings. So these are, if you say, different things which includes IoT. How IoT works? You talk about RFID. RFID used to identify and track the data of things. Then you are using sensor. What you do? RFID is nothing but sensor. This is a sensor. Then you have smart tech and nanotech. So sensor is to collect. What is the job of sensor? Sensor to collect and process the data to detect the changes in the physical status of things. Then what is smart tech? To enhance the power of the network by developing processing capabilities to different parts of the network. What is nanotech? To make a smaller and smaller things have the ability to connect and interact. So these are the different things which is working for IoT. Then we will talk about structure of IoT. Then you should write the deputy superintendent, na? You don't have nothing. You should write about the deputy superintendent also. Ask him. More than 567. Okay, give that letter. So if we say tagging, okay. Tagging of things. So what are the structure of IoT? First, if we see what is the tagging of things, real-time taken traceability and addressability by RFID. Feeling things. Sensors act as primary devices to collect data from the environment. Then syncing things, miniaturizations and nanotechnology has provoked the ability of smaller things to interact and connect within the things or smart devices. Then thinking things, that is embedded intelligence in devices through sensors has formed the network connection to the internet. It can make the things realizing the intelligent control. So you have tagging things, which is doing RFID, filling things, which is done by sensors, syncing things done by nanotechnology, then thinking things is nothing but embedded intelligence. So if we see the IoT history, already I told you, 99 it was there. This is basically, initially you start with radio frequency intelligence. Then current status and future prospect of IoT. So if we see world populations and connected devices, if we see are there, if you see here, more connected devices than people. So always devices will be more than people. So if you see here, in these slides, you are having connected devices per person is like, it is going to increase. Initial 0.08, in 2003, 2020 it becomes 6.58. Because now day by day we are connecting more things, more connected devices than people. So devices are more connected to the internet than people. The value is increasing. So if you see here, changes is the only thing permanent in this world. So if you want to do something, you must change. That is evolutions. Why evolution has come to the pictures? Because evolution will change. What you are using today, it may be obsolete after some times. You understand? See, you are using 3G or 2G, now you are looking for 5G. So if we change, that's a change the only thing permanent in this world. If we change only, you can go ahead. That is revolution is there. That is very, very important. Which country adopt changes faster, they used to go ahead. IoT as a network of networks. So if you see basically what I have seen, many devices are connected to internet. So what happens? They are nothing but network of networks. That is, you have educations, you have home, you have business, you have arts, you have other things, energy, transports, all are interconnected. They are individual networks, they are connected together, and you have securities, analytical and management is very important. See, when you connect two systems, doesn't mean that IoT works. You have some guidelines, you have some procedures. So you must see the security of the systems. Now if you will see in smart grid, very important topic is cyber security. So only if I talk about that things will be connected to what, you have to follow the procedures, you have to analyze the systems, and you have to manage the things properly. Then only you will have a useful outcome. Now if we come to knowledge management, turning data. Now if we say, we will be talking about knowledge management, that is about turning data into wisdom. So if you see here in this ladder, you can see here, in this ladder you have, initially you have the data, then once you get data, you will be getting the informations. Then if we see, once you get the informations, you will be getting the knowledge from informations. Then you have to understand the systems, then it is wisdom. So if we see, what happened? Initially data are less important. Sir, apa asanti more se cabin go? Avani net asche murji asche. Asanti. Oh, thank you. So if we see time bottle and jola. So if we see, you just see when you get only data, is it the important? Unless you don't use the data, what is the importance of data? It is not important. So when data become informations, see you got a data should convert to informations, information should give you knowledge, then once you knowledge you understand the systems, then you are become wise. So it is a wisdom. So it become more important. So benefit to humanity. Similarly, evaluated understanding, appreciation of why, what is understanding? Appreciation of why it happens. See, data means what? Data means suppose 5, 6, 7, 8, some symbols you are getting. Then once you get the symbols, when these questions, symbols are happened. You understand? You got, suppose you got 5 kilowatt. What is 5 kilowatt? Then you have to study this 5 kilowatt is a load. What happened to this 5 kilowatt? Whether load is increased or decreased? You understand? So this is nothing but you have arranged questions. Suppose you got some data. That is 3-phase fault. Data is telling current is 11 ampere. what is this 11 ampere? Why this 11 amperes happened? Then you got that 11 amperes happened, what happened, when happened. Once you know, you understand the answer is who and what. Then once you know who, what, where, when, all these things, data become informations. Then answer to how these things have happened. If you know the answer, you become knowledge. Then like this data you gather, then you understand why it happened, then you will be, if you know the reason, you become wise. You understand? The more data that is created, the better understanding and wisdom people can obtain. So if you will create more data, you will be knowing the system detail. What SCADA is doing? SCADA is supervising control and data action system is collecting the data. Once you have the data flow, you got more data, then it is easy to, if you see, once you get more data, then it is very easy to find out why it happened. Once you know why, then you understand the systems. Then it become, then if you get more data, it becomes wisdom. Okay. So knowledge management, that is turning data into wisdom. So now we talk about what the future of IoT. What happens when 50 billion machines become connected? So if you see, if more machines are connected, what happened? OT opportunities visualize analyticals, more predictive, employees increase productivities, machines are self-healing and automated, monitoring and maintenance is mobilized. The sky is not a limit, it's only the beginning of the IoT. So if more machines will connected, what will happen? Your hospital will be optimizations, your shipment is visibility is real-time data, you can do planning, brilliant rail yard will be there, brilliant hospital become brilliant, connected machines, intelligent medical devices, then you have smart grid. So when you see why you talk IoT, when IoT is connected to smart grid, then it become more efficient. You understand? So now you understand IoT is connected with smart grid means what? You have smart devices are there. You talk, suppose for a smart system, house should be smart. Correct? Or house should be, automation should be. Smart means what? It must use the automations. You have better control technology and you have better sensors. So you talk about house automations, then you talk about the control. So if we say, just think, as I told you, the sky is not the limit, it is only beginning the IoT. If you use more IoT, then it will be more beneficial to all. Because since smart grid, if you are using more IoT, then you are able to easily find out the defect. Then you can easily rectify the problem. So losses will be minimum. See, you use the sensors. What happened? It senses whenever fault occurs, so it will have self-healing properties, so it can be rectified automatically. Potential of IoT. Value of industrial internet is huge. Connected machines and data could eliminate up to 150 billion in waste across industries. Segments. Industries are aviation, power, healthcare, rail, oil and gas. Segment connected gas-fired generation, system-wide, freight, explorations and development. Type of savings, percentage of fuel savings, percentage reduction in system inefficiency, reduction in system inefficiency, reduction in capital expenditures. Estimated value over 15 years, it will have lot of value. It is increasing day by day. So GE estimates on potential of just 1% saving applied using IoT across global industry sectors. Unlock the massive potential of IoT, it improves performance, reduce cost, new revenue stream, create innovative services. So technology roadmap of IoT. If you see technology roadmap, first we are using RFID tags for facilitating routings, inventories and loss preventions. So demand for expedited logistics, then cost reduction leading to diffusion into second wave of applications, surveillance, security, healthcare, transport, food safety, document management. That is nothing but your supply chain helpers. Then you have vertical market applications, locating people and everyday objects, that is your ability of devices located indoors to receive geological signals. Then we have teleoperations and telepresence, ability to monitor and control distant objects, physical world web. So software agents and advanced sensors is futures. So the roadmap, how we are going from 2000 to present. Okay, so in future also looking more software agents and advanced sensors. You are using big data, you are using we'll see cloud computing. So these are a lot of applications are there where IoT plays an important role. So now we will go to the last part of our topic, that is IoT, Internet of Things. So ultimate goal of IoT is to automate human life. So what is the importance of IoT? Why should give so much importance? So most important thing is how to make automated human life. Few applications of IoT is building and home automations, manufacturing, medical and healthcare systems, media, environmental monitoring, infrastructure management, energy management, transportations, better quality of life for elderly. So basically you name it, you think anything you tell where IoT is not used, you don't find very difficult. So to take diverse applications, you have home consumers, that is light, bulbs, security, pet feeding, irrigation controller, smoke alarm, refrigerators, infotainment, washer, dryer, stove, energy monitoring. In home you can use IoT in all those following things. Then you have transport mobilities, that is your traffic routing, telematics, package monitoring, smart packing, insurance adjustments, supply chain, shipping, public transport, airlines, train. Then you have health body, patient care, elderly monitoring, remote diagnostic, equipment monitoring, hospital hygienic, bio wearables, food sensor. Then you have buildings, where you can have HVAC, security, lighting, electrical, transient, emergency alert, structural integrity, occupation. So basically if you show whatever you use sensors with internet, you can tell that is IoT. Sheet trigger industry you can use for electrical distributions, maintenance, surveillance, then sickness, utilities, smart grid, emergency services, waste management. So USD 41 billion by providing visibility into the availability of the parking spaces and across the city. Residents can identify and reserve the closest available space. Traffic wardens can identify non-complement uses, and municipalities can introduce demand-based pricing. So this happened when, in fact, when I was there in USA in the year of 2016, attending one conference and giving a talk there. That is basically, if we see ICRA, that is International Conference of Renewable Research and Applications, that I was there in California. That I am talking about the year of 2017. Even when I was in UK in 2016, that Birmingham, so what I have seen that their parking system is quite different than Indian parking systems. So you go to any place, automatically your gates will open and close, and based on that, when you park, they will charge you automatically how much hours you have parked. Okay. So their parking structure will say, Indian will say, you park anywhere, there is no restrictions, nothing is there, you should not pay anything. But their parking style and everything is different. They have taggers are there, and they have automatic meters are there, everywhere they exist. You pay the money, then you can park. Sometimes you can pay the money, then you can park here for how many hours you are parking. So their systems are quite different what I have observed compared to Indian systems. And if you see, basically I am talking about the USA, even when I was doing my research at University of Wisconsin in 2013, there also I have seen there are applications, if you see, basically smart grid. when I was working a project on microgrid, actually, our objective was that there was a laboratory I was working. The laboratory should be power supplied by wind and solar. So there is a microgrid I was working. So if we see their systems and Indian systems are quite different. They do a lot of practical things. And similarly, if you see when I was there in France in the year of 2011, even last year also I was in France before this corona starts. Luckily, I was there in 2000 by November, last November. So what I observed that their IoT plays very important role, and they depend on more on renewable energy, and they are very much energy conscious. See, every place will be automatic sensors will be there. So any hotel, anywhere you stay, lights will be on and off automatically. So that system, even when I was in France, I was cooking. In that room, there is some alarm was there. If there is small smell, I was using inductions, and Indian foods are more spice. So when I was preparing my food, due to spice, the smell has come. Immediately, alarm has rang, and the security and all people have come. They feel that something happened. Because they are in foreign, these things are happening. Because we Indians, what happened? I used to take a lot of spice. I was at the time used to a lot of spice. So a lot of people see their system of sensors is very much used compared to Indian systems. Indian, I have seen in few hotels they are using right now. But in fact, when I was there in 2009, I was in Singapore giving a lecture in an IEEE conference. That was my first foreign visit. So there also I have seen at the time also I was quite interested because that was my first foreign visit. So many things I have seen, their IoT implemented is very much high compared to India. And if you see time is going ahead, so now unfortunately we have COVID-19, but it gives the opportunity to us to use IoT much more. Now your digital platform, if you see most of the people are avoiding to go to bank and most of the things we are doing from the house. So in this present scenario, this IoT has a lot of importance. So one importance is, as I told you, smart parking or smart meters, efficient waste management in smart cities supported by sensing as a service. Here also very important is that, as I told you when I was in Chicago, I was there in Chicago for 6 months doing my post PDF. So the year of 2013, there first time I have seen how this wastage in three different, if you will see, three different waste, they will collect it and they will recycle it. So those things initially it was very interesting to see. Okay, now times have changed. India also they started the garbage in three different things. So if you see, waste management can be done also by using IoT, infrastructure with access to energy sources and long range data communications, garbage cans with low cost passive sensors, then garbage cans with active sensors. So these are things, garbage trucks as data collectors, who platform that support sensing as a service. So what you have? For a service you can give city council, recycling plant, manufacturing plant, health and safety authorities. Sensors in the event, the holy cow. You are using also sensing the cow. The world of IoT, even the cows will be connected and monitored. Sensors are implanted in the ears of cattle. This allows farmers to monitor cows' health and track their movements, ensuring a healthier, more plentiful supply of milk and meat for people to consume. On average, each cow generates 200 MB of information per year. Of course, nothing remains static, especially when it comes to the internet. Initiatives and advances such as Cisco, Planetary Skin, GE's Industrial Internet, HP Central Nervous Systems for Earth, and Smart Dust have the potential to add millions, even billions of sensors to the internet. As cows, water, pipes, people, even shoes, trees, and animals become connected to IoT, the world has the potential to become a better place. With a trillion sensors embedded in the environment, all connected by computing systems, software and services, it will be possible to hear the heartbeat of the earth, impacting human interactions with the globe as profoundly as the internet has revolutionized communications. This is given by Peter Hart. Well, senior researcher HPL. How much more IoT can do is only left to our imaginations. Internet of Things is the next stage of information revolutions and reference the interconnectivity of everything from urban transport to medical services to household applications. Object in the IoT will not only be devices with sensory capabilities but also provide actuations capabilities. On the other hand, IoT systems could also be responsible for performing actions, not just sensing things. Intelligent shopping systems, for example, could monitor specific users' purchasing habits in a store by tracking their specific mobile phones. So IoT application scenario you can see in shopping. When shopping in the market, the goods will introduce themselves. When entering the door, scanners will identify the tags on our clothings. When moving the goods, the reader will tell the staff to put a new one. When paying for the goods, the microchip of the credit card will communicate with the checkout reader. See, even if we'll say, as I told you, when I was in USA, I was buying the things from Walmart. So there were no persons for billing all those things. You keep the things, they will tell the price and pay the card, you can come out. So no need of any persons. So initially I was getting surprised. If you say those things to be implemented in India, I don't know whether in India, in the big department store, whether they are implemented or not. That is very unique, and that is also very safety. Basically, in this Corona, if you see time, you should not touch, if you say, or you should not come close to anyone. So how many steps have you walked today? That also can be done. How well do I sleep? Sleep statistics. See, in fact, this what you will see. My son used to have one watch. He should tell me I slept this many hours, I studied this many hours. Then I asked you, how do you know all those things? He tell you, see, data is that. And his watch will tell how many hours he has deep sleep, how many hours he is not having deep sleep. So all data will be collected from his watch. He used to have this band and he used to tell me that this many hours today I have deep sleep. I used to initially scold him that you are telling lie, but he used to tell me that this is showing, displaying, and whenever he tell that I studied this many hours, all will be recorded. You know, because a lot of sensors are there in that watch. I want to know more about myself, where you are going. That's I told you. If you have a band like watch, so this can be talk about yourself, how many hours you slept, how many hours you study, how many hours you disturbed, how many hours if you see you do other activities. These all can be done by that watch. The affinity of connections, how long it takes to get to work, the tone of your message, the amount of you text, tweet or update, how much exercise you are getting, how much you get distracted, all those things can be know about yourself from this. Thought control computing, the flagship product, MindWave is a headset that can log into a computer using just your thoughts. Researchers recently used the EEG headset to develop a car that can be driven forward with thought. NeuroSky smart sensors can also track your heart rate and other body's metrics can be embedded in the next generation of wearable devices. We make it possible for millions of consumers to capture and quantify critical health and wellness data. Home automations using IoT, as I told you, home automation is very important part of the smart grid. When you become making a grid smarter, your substation, stations, home, all should be smart. See, as a consumer, when you are smarter, then your grid will be smart. So how to do it? Home automation. The IoT applications span a wide range of domains, include home, various applications in home domains, smart lighting, smart appliances, intrusion detection, smoke or gas detectors. Smart lighting is for home saving energy by adapting the lighting to the ambient conditions and switching on and off, as I told you, or dimming the lights when needed. Key enabling technology for smart lighting include solid-state lighting such as LED lights and IP-enabled lights. Wireless enabled and internet-connected lights can be controlled remotely from IoT applications. Smart appliances, that is modern homes, have a number of applications such as TVs, refrigerators, music systems, washers. Smart appliances make the management easier and also provide status information to the user remotely. So appliances like your TV, washing machines, or iron, or if you see, many things can be made smart. Then intrusion detection, the system uses security cameras and sensors such as PIR sensors, door sensor to detect whoever entry or not and raise alerts. Alerts can be in the form of SMS or an email sent to the users. It can even send an image or short video clip as an email attachment. Smoke or gas detection. As I told you when I was cooking, there is a alarm has come due to smoke. Okay, smoke detectors are installed in homes and buildings to detect smoke. That is typically an early sign of fire. Smoke detectors use optical detections, ionizations, or air sampling techniques to detect smoke. Alert raised by smoke detectors can be in the form of signals to fire alarm systems. IoT applications, you see, this is an example of intelligent home. Your lights, speakers, windows, laptop, TV, tablet, speakers, refrigerator, lights, all can be smart, so that they can be smarter. Your garage door can be open, closed as I was telling you. Exterior lighting, smart egg tray. Egg minders synchronize with your smartphone to tell you how many eggs you have got at home when they are going bad. Smart washing machines. Smart ATAL is the first independent company washing machine signed to integrate in smart ecosystems covering a wide range of users. Smart lighting. Control balls one at a time or all together. Find just the right shade of the white, pick that perfect tone to match the moment. Smart AC can be used by, as I told you, mobile you can have a control. Smart sleep system. Visualize your sleep cycles, understand what wakes you up and compare nights. From the palm of your hand, you can control your personal smart weather systems, smart slow cookers, smart garbage cans, smart gardenings. Transportation you can use smart, as I think I have a talk by 11 o'clock, 11:30, as in my college, you are organizing on FDP, that is an application of control technique to control technique for sustainable energy. This is a 5-day FDP, it starts by 11:30. So I'll try to finish these lectures by 11 o'clock. Another 15 minutes are there. So this IoT application, if you see, basically these are the fleet vehicles drivers. You collect it, then you have key attributes. Basically you are looking for locations, vehicle metrics, driver behaviors, hours and miles driven. See, very important is that nowadays a lot of technology is coming. As you know that customers face a lot of difficulty when driver don't behave properly. So how to know the driver attitudes, driver behavior, whether they drunkard or not? That can be known by using IoT. Okay? So how many hours he may be tired, he may be tired by driving overnight, so he may take rest. So all these key attributes can be collected through IoT. So this is transcripts first to fleets, vehicles, drivers, then you have collect the data, then these are key attributes, you should collect it, then you should transmit it, then you should go to process, source data center, then web and mobile device should reports and from there you can analyze all those things. BMTC gets smart kicks off boss trackers. Then supply chain management is logistic, product design, warehouse, manufacturing. IoT architecture, if you see, here you can see integrated applications where you have smart grid, green buildings, smart transportations. So this smart was, very, if you say, very important. You talk about smart, when you talk about grid smart, that grid should be enough, if it's smart, to come across all those, if you see there is any abnormal behaviors, it must be able to solve it. Then green building, we are talking about eco-friendly building, green buildings. Green building, if you say, it should be away from these pollutions. So you are giving more importance to the renewable energy. Then smart transportation should be smart so that there should be no hectic. Then environmental monitoring. Then you have, these are all integrated applications. Information processing is nothing but data centers, search engines, smart decisions, information security, data mining. The network construction is, as I tell you, double one, wide area monitoring systems, then a personal area networks, wide personal area networks, WAPN, internet, WAMN, then LAN, there is wide local area networks, then you have GPS, you have smart device, you have RFID, you have sensors. What is IoT technology? What are going to use? You can use for hardware, then communication technology, protocols for IoT, software, and you have cloud platforms. So implementing smart objects. So this is a BeagleBone Black, Intel Galileo, Raspberry, this is Arduino. So these are these you can use. I think yesterday I came to know from Dr. M. Jagdish Kumar. Yesterday we have a talk on Arduino. Am I right? Similarly, Raspberry, this can use also, these are the smart objects can be used to use the IoT. So if you see board connections, how they are connected, I think yesterday we had a lot of talk. Arduino is very important, you know, you use a robot or use anything. Arduino is very important, if you see object, basically it is used by computer science students to do a lot of projects. Sensors and actuators are the technology we are using. You talk about electric, magnetic, leaks, levels, force, load, torque, machine visions, position, presence, proximity, motions, temperature, humidity. So these are the things where you can use the sensors. Acoustic, sound, vibration, chemical, gas. Sensors available in the markets. You have, these are the different type of sensors which is available in the markets, which few of them are given here, okay? You have IR emissions, linear Hall, photovoltaic. So these sensors have specific job, okay? And one sensor cannot do all type of job. So that's why you have two different type of sensors depend upon your problem. So IoT technology, communication, this is nothing but communication technology. As I told you, you are using 4G long-term evolutions. See, you have GPS, 4G, 3G, now we are looking for 5G. Correct? Then you have Bluetooth, Zigbee, Z-Wave, these are all the communication technology. These are very, very important for smart grid. GPS, if you see global position systems, see, if you are using PMU, you must have GPS. So these things if you see, this technology you are using to make the system more compatible and more cost effective, as well as you have to get better quality. See, smart grid, why you use smart grid is basically you are using to have quality things you should get, and you must be cost effective. See, you are talking about smart meters, it is already installed in many parts of the world, but India you are not installing because cost is much high. So if you are expecting that the government should give some subsidy so that you can use the smart meters. So these things are, if you see, that the technology evolution is going on. We are every time, why need 4G, 3G, 5G, why the evolution is there? Because each G or each generation, if you see, that uplink and or downloading will have higher speed. That's why you are looking for high Gs. Now you will see technology protocols, already I have told you these things. Technology cloud sensing as a, this is protocols as a service model, sensors and sensors owners, sensor publishers, extended services providers, sensor data consumers. So these are sensing as a service model, whatever you are using. Technology challenge. What are the technological challenges are there? As you know that IoT is having a lot of, if you see, importance in day-to-day life. Still then, why you are not implementing? At present, IoT is faced with many challenges such as scalabilities, technological standardizations, interoperabilities, discover, software complexity, data volumes, interpretations, power supply, interactions, short range communications, wireless communications, fault tolerance. So what the criticisms, the last slides I am presenting, that is criticisms and controls of IoT. So scholars and social observers and pessimists have doubts about the promises of the ubiquitous computing revolutions in the areas of privacy. So people are talking, as I told you, smart meters. When I was met my friend from Australia, you might have known Dr. I will say Dr. Kalam, he was talking about this smart meters. It may leak the privacy. It may be unsafe. There is a lot of topics going on cyber securities. So what I'm telling, as you know that this safety is very important. So you are not able to implement. Sometimes R&D and all those things may be also damage to health. Some news are coming. So unless you don't do research thoroughly, implementing things will be difficult. Then automatic and control, social control. Then people see, as I told you, smart meters, it may be costly. People may not be aware. See, long term it may be cheap. You use renewable energy, initial cost is more. But long term there are a lot of benefits are there. So political management and vote bank politics. See, if you make poor, illiterate, you can get vote more often. So people may think that if you will be doing all facilities, they may expect more and more. So this politically they have to calculate how to win the vote bank. Then designing environmental is very important. When you change the things, it may affect your surroundings. As I told you, you talk about RFID, all those things, you may have some impact to the health. Influence human moral decision making. Then everything you may think not decision taken by computers may not be correct. These are the reference. I think, as I told you, I have few minutes to interact with you. So I have completed my talk. I must thank to my friend Dr. M. Jagdish Kumar for giving these opportunities, and also thanks to Thairam Institute of Technology for inviting me to deliver the lectures on IoTs. This is, I think, if you need, I can share the slides. It gives a lot of information about IoT. If you need any more things, I can help you. As I told you, my subjects are basically research subject is smart grid. So once again, thanks to all the audience who has been listening to me for last 1.5 hours with the patiently. So thank you to all. Now this time for question answer, you can ask me. Yes, Dr. Jagdish Kumar.
So any questions from the audience?
My 2 minutes is there. Yes, Dr. Jagdish Kumar.
So we can close the session. Thank you.
So we'll close it.
Thank you, sir.
Thank you, madam.
Thank you, Dr. Edwin, sir, for handling this IoT technologies and standards and IoT for smart homes.
Yeah.
Thank you for sharing your valuable knowledge, sir. You
Yeah,
made this
thank
session wonderful. Thank you for your time, sir.
Thank you, madam. Thanks for giving chance. Thank you.
Thank you, sir. We can close the session, sir.
So we'll close it. Okay. Thank you.
Okay, sir.
Thank you.
Participants, please stay here for filling the feedback form. It will be open for another half an hour up to 11:30. I will be posting the link soon. Thank you.